Ni hao. Well, that's the way we say hello in Hong Kong. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of physics. Now, children, this is Chi Lin Nunnery, Salmon, Hong Kong. It is here that you will get to see a serene environment contrary to the bustling life of Hong Kong. It was built in the 1930s by the Tang dynasty. Believe me, it is made all of wood and there is not a single nail. Here you will get to see lotus in a pond, bougainvillea and bonsai tea plants. Make sure to have almond tea, which is the famous dessert around here, and also to tell all the people of Hong Kong that you get to meet, Ni hao. In this note, children, I'm going to start off this lecture in physics, where today we are going to take the discussion on numericals further. So be ready with the formulae that we've discussed earlier. I'm going to ask it to you, and if you can't answer, be ready. Okay, now the first sum that I have for you people is this. Quickly give it a try, and after that I will be discussing the sum with you people. Remember, learning formulae is a very important task, and if you don't do so, then it will not help you in solving the numericals. And then I'm also going to be hard on to you people, right? So learn it. Okay, now children, in this question you've been given here, there is a bulb filament when cold has a resistance of 1 ohm. Okay, a source of 3 volt lights it up when it draws a current of 0.3 amperes. Find the resistance of the bulb when lit and explain the difference in resistance. Now here, children, remember that whenever we talk about a filament in a bulb, right, then the filament gets heated up, and when it gets heated up to a temperature which is more than 1500 degrees centigrade, then it starts giving illuminance, or in other words, it starts giving visible light. Thus, if you talk about a filament when it was cold, that means it was approximately at the room temperature, there has been a big heating of that filament which has happened, due to which the resistance of the filament increases. This is what is being talked about. So, when a bulb filament is cold, then its resistance will be less. However, when it is given light energy, then obviously it has become very hot, and that is why its resistance will also increase. So this is the reason that you require a right. Moreover, here we'll be finding out what is its resistance when it is hot. So now, children, here, as you know, that the formula that we're going to use is that of the Ohm's law, right? I'm sure you people must have learnt it. That is, we have V to be equal to I times of R, where V is the potential difference across the ends of the filament wire, I is the current which is running through it, and R is the resistance. As here, we've got to find out R, so we'll be making R the subject of the equation. So R will become equal to V upon I. Now here, children, what we're going to do is we will now be substituting the value of the voltage which is across the ends of the wire, which is 3 here, and then further we will divide it by the current, which is 0.3 amperes. Now, children, we require to shift decimal and multiply the numerator by 10. Now further, 3 gets cancelled, and thus this will come to 10 ohms, and that, children, will become the answer. So here you can get to see that initially the filament of the bulb had a resistance of 1 ohm. Later, after it is lit and it starts giving light energy after having some illuminance because of the high temperature, then its resistance becomes equal to 10 ohm. So this is the difference between the filament when it was cold and the filament when it is red hot, giving some light energy. Its resistance also has become very large, 10 times of what it was earlier. So children, I'll just quickly discuss the sum all over. In the question, you've been given that there is a bulb filament which has a resistance of 1 ohm when it is cold, and when there is electricity which is passed through it, then it becomes very hot and it starts emitting light energy, and that is then the resistance of the wire becomes larger. And that large resistance is what you're going to find out when the potential difference across the ends of the wire has been given to you as 3 volts and the current which is passing through it is 0.3 amperes. So here, children, as we are dealing with the potential difference, the current and the resistance, so we call in the Ohm's law, which is equal to IR. And here, children, as resistance is to be found out, so we make R the subject of the equation by dividing the left hand side V with I. So we have V upon I, which becomes equal to R. Now here, children, we substitute the value of the voltage which has been given to us, that is 3 volts, and divide it by the current, which is 0.3 amperes. Now here we shift a decimal in the denominator, so we have a power of 10 in the numerator. 3 gets cancelled, as such 10 ohms, rather ohm, becomes the answer to this question. Why not ohms? Always remember that whenever you write a unit, then it is not a plural even if it is more than one. It is always said to be a unit entity. For that matter, if suppose we talk about 20, then it is not 20 newtons, but it is 20 newton, right? So when you write it, you will write it as NEWTON, which is the name of the scientist, but here we are talking about the unit, so we won't write it with capital first letter, right? And neither are we going to write a S, because this, although it's a plural, because it's not 1 newton, it is 20 newton, but here conventionally we don't write a S, right? That is because there are units which are with S, like second. So how can we write a second S, right? So that is the reason why we do not write a S after the unit. And this is how the units, although they are plural, but they are written like singular. Okay, now children, I hope you people have understood this question. So are you understanding all that is there in this lecture? Liking it? Obviously, then you should press the like button. And if you've yet not subscribed to my channel, do subscribe to my channel, and further do share it to the people who will be requiring all of this study which we are doing in this lecture. Do press the bell icon also, so that you get all the new lectures which I put in my channel for your help. And obviously this provides a big motivation to me if you write a small message as to how you like the lecture and what else you would like to learn. And then I will make sure that I put up an interesting lecture which you all will like and which will surely be beneficial to you. Make sure to watch till the end of this lecture so that you are able to get all that I have prepared for you people, which will make your physics gradually better. Okay, now children, we will look up the next sum. So this, children, is the next sum. Quickly give it a try, after which we will be discussing the sum. Right, now let's discuss the sum. If you think that you require more time, then you can pause the lecture and give it a bigger try, right? That is all on you. Always try out a new sum, howsoever hard it is. Just try thinking which are the different formulae that you can apply. Apply it, try to get to an answer, reason it out, and if suppose you are right, then that's very good. But if suppose you made a mistake, then from the solution of the question you can make out what your error is, and I'm sure you will not make the error next time. Okay, so let's look up this question. In the question you've been given, calculate the resistance of 1 kilometer long wire of radius 1 millimeter when the resistivity of the wire of copper is 1.72 into 10 raised to the power minus 8 ohm meter. So here we've been given few entities and we will quickly register all of those entities. The first is we've been given that the length of the wire is 1 kilometer. So as it is 1 kilometer, so we will write this to be 1000 meter. As whenever we talk about kilo, remember kilo means 10 raised to the power 3 or 1000 for any unit which comes after K, that is kilo. Next, we now talk about the radius. So the radius of the wire has been given to you as 1 millimeter. Milli means 10 raised to the power minus 3. So if you got to write this in the SI unit, which is meter, so this will become 10 raised to the power minus 3 meter. So here we've been given the radius of the wire, as whenever there is a wire, it is expected that it is going to be cylindrical. So at every cross section we get a circle, and the area of cross section thus, which is going to be used now, is pi r square to be put in the formula. Next, we've been given the resistivity of the wire of copper, right? And the resistivity, as you know, we will write it with rho, and its value has been given to you as 1.72 into 10 raised to the power minus 8, right? This is in the proper SI unit, so we don't require to write its unit. It is understood. Now children, as the resistance is required, and you know that if we talk about the formula of resistance, capital R, the resistance, is equal to rho L upon A, where here children, rho is the resistivity, right, or the specific resistance, L is the length of the wire, and A is the area of cross section. So here children, what we'll do is, now we'll keep the value of the different constants and find out the value of this 1 kilometer long resistance wire of copper. So first we keep the value of resistivity, which is 1.72 into 10 raised to the power minus 8. Further multiply it with the length, which remember is 1 kilometers, thus it is 1000 meters. Here you don't require to write the units, as you're converting them into SI units, and in the denominator now you require to keep the area. Like I told you, when you talk about the wire, remember the wire is cylindrical. As the wire is cylindrical, so obviously at every cross section you will get a circle, and the area of this circle is going to be this capital A. As you know that area of the circle is pi r square, so this is what we're going to substitute here. That is pi into the value of r, that is 10 raised to the power minus 3 whole square. So here children, we're going to further calculate this. Now next what we do is, we can now write this to be 1.72 into 10 raised to the power minus 8, right, which is further multiplied with 10 raised to the power 3, that is 1000, and in the denominator we now have 3.14, which is the value of pi, right, and further here then we multiply this with 10 raised to the power minus 6. Now here children, remember that if you have some a raised to the power m, which is whole raised to the power n, then by the rule of indices or exponents, we know that that becomes equal to a raised to the power m into n. So we apply this rule as such here. Next, now this becomes minus 3 into 2, that is minus 6. Next, now we handle these numbers. Now we will shift a decimal and another decimal, shift a decimal and another decimal. In the numerator we will have 10 raised to the power 2 because of this shifting of decimal, and in the denominator also we will have 10 raised to the power 2. As you can see, both of these powers of 10 will get cancelled, right, and after that now we will cancel the numbers and then find out the value of the resistance of the wire. Next, now we have 3.14 and 1.72. We can cancel them off, right, with 2. So we have 2, 1 is 2, and then we have here further 10, right? So 2 5 is 10 and 2 7 is 14, and then further we have 2 8 is 16 and 2 6 is 12. So this is 86, which is divided by 157, right? Now further we can calculate this. So here further we have 86 divided by 157, and if we talk about the powers of 10, we have 10 raised to the power minus 8 plus minus 3, and further we have plus 6. Now how did this happen? I'll quickly tell you again. Now if we talk about some a raised to the power m, which is multiplied with a raised to the power n, then that becomes equal to a raised to the power m plus n, right? This is another rule of indices that we have. Further, if we have some a raised to the power minus m, then that can be written as 1 upon a raised to the power m. So as such, here you had 10 raised to the power minus 6. When it came over to the numerator, it became 10 raised to the power 6. And since all of these are powers of 10, these powers thus get added. This is how we will get the final power of 10 now. And now if you calculate this, this is going to become equal to, we will now talk about dividing 157 with 86. So obviously it will go 0 point, and then we'll have 860. Now we talk about 157 and we will try it out 5 times. 5 7 is 35, 3 remainder, 5 5 25, and 3 is 28, 2 remainder, 5 and the 5, 5 and 2 is 7. That comes nearly correct. Now if we add 150 to this, it's going to become larger. As such, this is going to go 5 times. And then further we will have 860, from which 785 is going to get subtracted, right? 5 and 5 is 10, then we have 9, and 7 is 16, right? So we now have 750. So this will thus become equal to 0.55, as again with 157, when 5 is multiplied, you will get a number which will give you this as the correct quotient. Now children, further if you talk about the powers of 10, then that is going to become equal to 8 and 3 is 11 in negative, and plus 6. So this will become 6 and 5 is 11, so it will become 10 raised to the power minus 5, right? And this in ohms will become the final answer. So if you want to write this keeping one whole number before the decimal point, so this can be written as 5.5, right? And as you have shifted one decimal towards the left hand side, thus here you will have to increase the negative power by 1, so it will become 5.5 into 10 raised to the power minus 6 ohms, which will become the final answer. So children, I'll just quickly discuss this all over. In the question, you've been given here that you've got to calculate the resistance of 1 kilometer long wire of radius 1 millimeter when the resistivity of the wire of copper is 1.72 into 10 raised to the power minus 8 ohm meter. So here children, as the length has been given to you in kilometers, so if you convert it to meters, it will become 1000 meters. Similarly, you've been given the radius in millimeter. If you convert it to meters, it will become 10 raised to the power minus 3 meter. Now for the children, we use the formula R is equal to rho L upon A. So we keep the value of rho, which has been given to us, multiply it with the length of the wire, which is 1000, and divide it by pi r square. Now here children, as the wire is always cylindrical, so the cross section will always be circular, and the area of cross section of a circular, that is a cylindrical wire, is going to be pi r square. So it will become pi times of r, that is 10 raised to the power minus 3 whole square. Here we used a rule, a raised to the power m whole raised to the power n will become a raised to the power m into n, right? As such, this will become 10 raised to the power minus 6 here. Further, 1000 can be written as 10 raised to the power 3. Now we shift 2 decimals in the numerator and 2 decimals in the denominator. As such, we have 10 raised to the power 2 in the numerator and the denominator, which get cancelled. Then we have powers of 10 to handle. So remember, when we take a power which is in negative, right, to be made to be positive, right, then from the numerator it changes over to the denominator. And if suppose you've got to take a number which is in the numerator to the denominator, then the sign of the power reverses. If it's negative, it will become positive. If it's positive, it will become negative. So this is how 10 raised to the power minus 6 coming over to the numerator becomes 10 raised to the power 6. Then we have another rule. If the bases are the same, then keeping the base to be the same, indices are added when two such exponential numbers are multiplied. So as such, here we'll have 10 raised to the power minus 8 plus 3 and plus 6, right? So thus here we have minus 8 minus 3, which will become minus 11, plus 6 and 5 is 11, so it will become 10 raised to the power minus 5. Now here children, next what we do is we talk about now dividing 172 with 314, and that approximately comes to 0.55. We keep one number before the decimal point. As such, 5.5 into 10 raised to the power minus 6 in ohms will become the final answer. Now here I'll quickly explain, because you're shifting a decimal, so obviously it is getting divided by 10, and as it is getting divided by 10, that is the reason a power in negative of 10 is getting increased, and that is why it becomes 5.5 into 10 raised to the power minus 6 ohm, and that children will become the final answer. Is this clear with everybody? Sure? Really? Good. Now, children, after this, I have another sum for you people, and that sum is in the next lecture. So, that is all for now. I'm sure all of this you people have understood. Make sure to follow my lectures one by one so that you have a very good and thorough understanding of electricity, and do practice all of these sums once more so that every understanding is very well assimilated with you people. Bye for now and have a nice time. Bye.